All right. Hello. Good morning. You can scan your QR code, and then I can also send through the YouTube, right? Okay, and then also from your Telegram. So I hope you can hear my voice. Okay, right? Hear my voice, right? And then good evening, Wan Ting Lee. All right, good evening to Chiu Ziong Yan. Okay, we are continue our lesson on the chapter 7. Right, I think we are complete about the theorem Gauss-Green, but we don't know how to find the eigenvalue. Okay, right? Do you know how to find eigenvalue? To find the value, okay, of the eigenvalue, right? So now let's we continue, okay, to solve this problem. Do you know how to find eigenvalue associated with the eigenvectors? So this is my question, right? Right. So do you know how to find the eigenvalue associated with the eigenvectors? All right. So now if I can share screen with you, all right. The eigenvalue. Okay, let's we continue. I'm stop sharing. Hi, Chen. All right. How are you? All right, so now I'm stop sharing. I want to share with you the subject today, right? I can go to Gauss-Green theorem to find the eigenvalue and eigenvectors. Okay, I already sent to your Telegram the link to for this subject. Okay, now let's be focused about how to find eigenvalue and eigenvectors. So this is my question to you now. Right. So since we know the Gauss-Green theorem, okay, to find the region, the area, the location of the eigenvalue, so we know that there is another, okay, there is a specific, there is a solution to find Ax equal to F, okay, by finding the eigenvalue and eigenvector. We call lambda as eigenvalue and V as eigenvectors, right? To solve Ax equal to F, okay, that is also can be represented as a AV equal to lambda V. V is a vectors, lambda is eigenvalue, okay, and then we can rewrite again as a AV minus lambda V equal to 0. This is common in mathematics. All right, so you bring all V on your right hand side and then we put identity. Identity is also the vectors. A is a matrix 3 by 3 minus lambda times identity, all right, and then times V is equal to 0. So the polynomial, okay, of degree n, okay, polynomial of degree n, or we call as a P, all right, sometimes we call rho, right, where we can write as A minus lambda I, absolute value equal to 0. So the rho, or we call as a characteristic polynomial of A, all right, is equal to 0, is equal to 0. So to fulfill this condition, all right, we are using Gauss-Green theorem to find the lambda. We already learned before, all right, we already learned before, all right, the location to find lambda. But now we want to find the value, okay, the value of lambda. This is my question now. How to find the lambda, the eigenvalue? So we are using power method. Okay, we are using power method after applying Gauss-Green theorem to find the location of lambda. And now we want to find a specific eigenvalue. Okay, we want to find the specific eigenvalue. So my question here, how many eigenvalue? How many lambda? All right, you want to find how many lambda, all right? So since matrix A is 3 by 3, so lambda is 3. How many lambda you have? 3. Lambda 1, lambda 2, lambda 3. Lambda maximum, lambda minimum, and the lambda between lambda 3 and lambda 1. So we have a 3 lambda. How to find lambda? All right. So the dominant or the maximum lambda we call, we call dominant or maximum lambda, we can use power method. So power method, is used to find dominant, dominant lambda. Okay, what is lambda? Is eigenvalue. Okay, so we want to find the dominant lambda. All right. So if you have a problem, let me know. All right, because now I'm going to find the lambda, the 3 lambda, maximum, minimum, and the lambda between the 3. Okay, and then the maximum we call dominant lambda. We can solve using power method. We can use power method. All right. So now let's focus on the power method. What is a power method? Right. So the next question is, what is a power method? All right. So there are 3 steps to find lambda. Okay, lambda 1. Lambda 1 is an eigenvalue, right, by using power method. All right. So, and then to get a minimum lambda, okay, which is lambda 3, minimum lambda, we're using shifted power method. And then to get lambda 2, all right, we have a formula to find the lambda 2, the lambda between lambda 1 and lambda 3. All right, lambda 1 is a dominant, is a maximum, lambda 3 is a minimum using shifted power method. All right, so now, we are using Gauss-Green theorem. Okay, we know already to find the radius. Okay, you know what is a radius? This is the area 1 of the lambda. C is a circle where z minus aii less than ri. Ri is a summation of aij where I is not equal to j. Right, you have to know A11, A22, A33. Right, this is considered as the center of the circle of the radius. Okay, so now we want to apply the Gauss-Green theorem for this matrix 3 by 3, and then A11 is 4, A22 is 3, A33 is 9. All right, so you can see here the matrix is dominant at the diagonal. Okay, aii will be the center of your radius. Okay, so we learned already, okay, last lesson, so I don't want to repeat again. And then you have a 3 lambda here, lambda 1, lambda 2, lambda 3. Lambda 1 will we can find using power method, lambda 3 by using shifted power method, and lambda 2 is between lambda 1 and lambda 3 using a specific formula. We are going to give you a formula. So Gauss-Green theorem, they can find the lambda which is inside the circle. In this case, since we know the center, okay, of the circle is aii, A11 is 2, A11 is 4, A22 is 3, is 2, and A33, okay, is a C3, is a 9. So you can see here the radius is R1 is 2, R2 is 1, and R3 is 3. So from here you can see you can find the barrier, the boundary of the circle. So the boundary of the circle for circle 1 is 2 and 6. The boundary for circle 2 is 1 and 3 because the radius is 1. And boundary for circle 3, the radius is 2, the center is 9. So the boundary is between 7 and 11. All right. So the area to find the eigenvalue is between C1 union C2 union C3. So the answer is, okay, eigenvalue is somewhere between 1 to 6 and 7 to 11. So this is the answer. Okay, using Gauss-Green theorem, the lambda is between the C1 union C2 and union C3. So now I hope, okay, I'm really hope you can answer this question. Where is the location of the eigenvalue? You know what is R? R is a summation Aij. I is not equal to J. You know how to find the radius? Radius is Z minus Aii. All right. So this is the way how you find the boundary for every circle. All right. So be careful because there is a question here, how to find the eigenvalue or lambda, all right? The next question is how to find the specific lambda, the eigenvalue. Lambda 1 is a dominant, lambda 3 and lambda 2, all right? Okay, so now let's refocus, okay, to the how to find the lambda. That's a question that we can answer, all right? How to find the lambda after knowing the circle, where is the location of eigenvalue. Okay, we use power method. Okay, power method is very simple. It's just to find the largest eigenvalue or dominant eigenvalue or lambda 1, okay, which is lambda 1 always greater than lambda 2 and lambda 2 always greater than lambda 3 because the size of matrix is a 3 by 3. If 4, maybe greater than lambda 4. So the formula is a vector vk plus 1 equal to 1 over mk plus 1 avk. What is a v? V is eigenvalue, eigenvectors. What is m? M is a eigenvalue. Okay, the mk plus 1 is a maximum value that you can get from the vk plus 1, right? Mk plus 1 is a eigenvalue, k is an iteration, AV is a matrix A times vector eigen. So since you know that this is an iterative, you need to know what is a V iteration 0, V0, right? So the first iteration for V0, vector eigen 0, will be given in the question, right? So you need to do, okay, the matrix multiplication AV0 first phase, and then find the V is 1 over mk plus 1 avk, right? How to find mk plus 1 is a maximum value from the avk, all right, from the matrix multiplication AV, and then you can get V and then generate this one, okay, this iteration until you stop the iteration. The condition is mk plus 1 minus mk is less than epsilon, right? So iteration, power method is an iteration method, right? So to fulfill the process of iteration, you need to develop the table, all right? The table between k is iteration, the table for vk, eigenvectors, and then do the multiplication avk, all right, the matrix, okay, avk is a vectors, and mk plus 1 is a maximum value from avk, which is negative, okay? You can choose negative or positive value. All right, you stop the iteration when the condition mk plus 1 minus mk is less than epsilon. All right, so in this case, okay, I want to express here, in this case, all right, you are quite familiar with method we call as Newton method, okay? Newton method, all right? You're quite familiar with the Gauss-Seidel method, all right? And then you're quite familiar with the iterative method, all right? So this method will be applied, okay, will be applied to find the maximum m. M is an eigenvalue, all right? Eigenvalue. So we are going to use this concept in chapter 2 or chapter 3, iterative manner, right, to find the m. Okay, let's we go to complete the table, right? Let's we go to complete the table. All right, so now let's we go to the table, okay, and then let's we go to the example, right? All right, so let's, if I can share with you the example to find the eigenvalue, right? We stop sharing, okay. Okay, we stop sharing. All right, we change the video to the other material. Okay, my question here, how to find the maximum or dominant eigenvalue, all right, using power method. What is a power method? It's an iterative method to find the maximum lambda. There are three lambda, all right, there are three lambda. So we want to find the maximum, all right. So now how to find, my question is how to find maximum or dominant, sometimes we call dominant eigenvalue, or we call as a, sometimes we call as a lambda. All right, so now let's we go. All right, how to find the lambda one, or sometimes we call as a lambda one. All right, okay, let's refocus to our lecture. All right, we know that the power method is a vk equal to mk plus 1 avk, right? This iteration. All right, we want to find the dominant eigenvalue from matrix 1, 2, 3, 3, 2, 3, 4, 4, 5, okay, 3, 4, 5. So the dominant A11, A22, A33 at the center, okay, at the center. And then you also given the eigen vectors is a V0 equal to 0, 1, 0. This is start the iteration, right? Okay, from A you can find the region of the eigenvalue by using the Gauss-Gilling theorem. But in this question, they ask you to find the eigenvalue, right? So before this, we use Gauss-Gilling theorem to find the location of lambda. How many lambda? Because the matrix is 3 by 3, we have 3 lambda, right? So now, the second step is to find a dominant eigenvalue. It's a lambda 1 from the using the power method, right? So this eigenvalue associate with the vector eigen V1, right? So we need to find the V1. V1 is a Vk plus 1 in the formula of power method. Okay, we give you the initial condition V0. V0 is a V1 equal to 0. The element, yeah, this one is not vector. The element V1 is equal to 0, V2 equal to 1, and V3 equal to 0. This one is a element of the vector. Okay, you see I bold the V is a vectors V0. All right, I want to apply the power method, set in my mind. Okay, the step number 4 is to apply the eigenvectors and control the mk plus 1, okay, less than epsilon. All right, so now I write in the step here. What is the first step? Find AV0. Okay, A, you know already A, the value A is a 1, 2, 3, 2, 3, 4, 3, 4, 5 times V0. V0 is 0, 1, 0. Right, so you can get AV1. AV0. After you get AV0, you can get lambda 1. Lambda 1 is a MK1, is a maximum value, maximum from the table, which is a very maximum, 3, 4, 2, 3, 4, which is maximum. Maximum is number 4. So you can create V1 is a AV0 divided by lambda 1 equal to 1 over 4, and then matrix AV0 already got from the previous step is a 2, 3, 4. All right, so you will get the vector iteration 1. All right, you repeat again this formula of power method because lambda 1 minus, okay, lambda 0 from the previous is still not less, it's less than epsilon. All right, so you continue to AV1, okay. From the matrix AV1, you can get the dominant lambda 2. Okay, lambda 2 is a 9.5. You can do it by using the matrix multiplication AV1. You can get V2. V2 is 1 over lambda 2, the dominant that you get from the matrix AV1. The maximum is 9.5 times, okay, AV1. AV1 is 5, 7.25, 9.5. So the dominant is a 9.5. All right. So because you minus 9.5 minus 4 is greater than epsilon, you continue to find lambda 3. All right. Lambda 3 is maximum from AV2. You need to do AV2. All right. You need to do matrix AV2. All right. So this is the process where you can use calculator to control your accuracy of your calculation. Yeah. And then you can find V3 is a 1 over 9.5. 9.5 is a maximum, is a dominant from AV2. All right, so you can get V3. Then continue this process. Continue this process and develop the table. Why? Because this table will help you to control the iteration. Right? The iteration controlled by the table, okay, because M6 minus M5 is less than epsilon. What is M? Is an eigenvalue. How to get M? From the matrix multiplication AV. All right? From matrix multiplication AV, which is a maximum value. All right? 9.6235. Okay, the maximum you control, and then when you minus, is less than epsilon, you end the iteration to get V6. V6 is an eigenvalue associated with the dominant eigenvalue. V1 is an eigenvectors associated with the eigenvalue. All right. So now I want to ask you a question. All right. This question, okay, how to generate the table of power method. This is my question. How to generate the table of power method to find the dominant of eigenvalue, lambda 1. Lambda 1 is a eigenvalue, is a 9.6235. Can you, this is my question, can you generate in 10 minutes? So this is my question. Can you generate this table in 10 minutes? Because you need to do matrix multiplication AV. You need to find MK plus 1, the maximum value from AV. And then you need to use power method to get V. V is a 1 over M A times V. You can do it in 10 minutes time. All right, so this is my question, right? This is my question. All right, okay. From here, you can find the dominant, okay, eigenvalue 0.6235, and then the solution is an eigenvector 0.547 is a V1, V2 is a 0.7623 is an element, element for AX equal to F, the solution for linear system that you learned in chapter 1. And then 1.0, all right, 1.0. This is my question, all right. Can you apply the power method iteratively? How many times? 5 times, okay, 5 iteration to find the dominant MK plus 1 or lambda, all right, or eigenvalue, all right. And then can you find the eigenvector associated with the lambda 1, all right, by control the MK plus 1 minus MK, all right. In our case, K is a 6. So this is my question. All right, the next question, okay, let's refocus, okay, our finding here, okay, okay, how to find other eigenvalue, because we have dominant now, one eigenvalue, we apply power method, all right, the matrix A is original from the question. So now my question here is how to find other eigenvalue. We have lambda 1, we have lambda 2, we have lambda 3, all right. So in this case, we suggest you shifted power method to find the minimum, okay, the minimum eigenvalue. Okay, just now is a maximum, all right, and then we also have the maximum eigenvectors. But now the question is how to find lambda 3, which is associated with the vector eigen, okay, V3. So in this case, we need to apply, okay, shifted power method. All right, so I hope that you can go to exercise 7.1, yeah. All right, because this is very easy to find the dominant eigenvectors using and dominant eigenvalue using power method. Right. So again, how to do that? Develop the table. Find the V naught. We need to have an initial value of the V, and then generate the matrix AVK. From the AVK, you can get the maximum value, and then you put as a MK plus 1, and then you do it again, the process of power method. Stop the iteration when K plus 1 minus MK is less than epsilon. All right. So you are going to apply this strategy. All right. You will apply this strategy using power method, okay, to create the shifted power method. All right, shifted power method. We're still using the same process. All right, for the shifted power method by changing A to B. What is A? Is a matrix that we given in the question. We change A to B. All right. So now we are going to solve this problem using shifted power method. So I want to to make sure that you know how when you are using power method. All right. So the next question here, how to find this now is dominant kan? So now is a minimum eigenvalue, which is I call as a lambda 3 kan? I call as a lambda 3. So this is my question here, how to find the other lambda. We have 3 lambda because matrix is 3 by 3. Okay, if 4 by 4, you have 4 lambda. You have 4 eigenvectors. All right, you have a maximum eigenvalue, minimum eigenvalue, and then you need to find another 2. All right, so now to answer this question, all right, to answer this question, I want to share screen, okay, with you for shifted power method. All right, why we need to move to shifted power method? Because, okay, shifted power method will help us to find the minimum lambda. We have 3 lambda, so we want to focus to minimum lambda. Okay, let's we go to the shifted power method. Okay, I know you quite not familiar with the table. However, the process to generate the lambda 3 or minimum eigen value is just similar to the AV equal to lambda, okay, lambda V. All right, and then from here, okay, from the power method, okay, you know the A minus lambda IV equal to 0. Right? So you can solve the dominant eigenvalue using the power method. But in this case, for shifted power method, all right, so you get A minus PI, P is a shifted factors, and has a same set of lambda and V. Okay, how to find P, and then how to generate a new matrix from A. So you can get A minus PIV is equal to AV minus PIV. Okay, all right. So I is an identity. All right. Okay. So we can express this equation very simple as a V lambda V minus PV. All right, where lambda minus P is an eigenvalue, okay, for matrix A. Lambda minus P is eigenvalue for matrix A. So now we change A, because A now will be replaced to the new eigenvalue, lambda minus P. Alright, so now lambda 1 minus P, lambda 2 minus P, lambda 3 minus P are the eigenvalue, okay, of the A minus PI. Alright, A minus PI. Alright, so now we are going to generate a new matrix B is equal to A minus Pi, right? What is a P? P is a shifted power or the eigenvalue. What is a P? P is a shifted vectors or eigenvalue that you get from the power method. Okay, that you get from the lambda 1. Alright, so let's we change B equal to A minus lambda 1i. Alright, so we can change because lambda 1 always greater than lambda 2, always greater than lambda 3. Alright, so now, okay, be careful now. Okay, we want to find, okay, the the minimum, okay, the smallest magnitude of the eigenvalue. We already get lambda 1 from the dominant eigenvalue using power method. All right, so we want to find lambda 3. In our case, because matrix is 3 by 3, we want to find lambda 3. Okay, by using the shifted power method. Right, we are using the same question. We want to find lambda 3 and we want to find another lambda, which is lambda 2, all right, using shifted power method, all right. And then to get lambda 2, there is a formula you need to remember using the trace A. What is trace A? Is A11, A22 plus A33 is a diagonal of the matrix A. You can get lambda 2. However, at this moment, let's we go how to find lambda 3. All right, so now to get lambda 3, all right, you need to use a power method first, okay, to find a dominant lambda 1. In our case, okay, lambda 1 using power method, we repeat the formula of power method. All right, what is the formula of power method? You see here, the formula of power method is a Vk plus 1 equal to 1 over Mk plus 1 Avk. All right, so we repeat. We already know how to use power method. We know how to develop the matrix. The matrix is a V and AV and Mk plus 1 is a dominant value from the matrix multiplication AV. All right, for example, here you can see, all right, I focus here, Mk plus 1, okay, is a 4, the dominant one, okay, 4, negative 4, 5 is 5, okay, 5.6, okay, 4.2, negative 5.2, the maximum is 5.6. All right, so now Mk plus 1 from AV, when iteration moving, the maximum is 6. All right, so you stop the iteration because 6 minus 6 is less than epsilon. All right, so this is the way we get from the matrix A. Okay, the A is a given in the question. All right, from where? Come on, we we go to page. Come on, this one. All right, go to page. Come on. Okay, I move to page. We go to page chapter 7. Okay, shifted power method. All right, we go to page chapter 7. Yeah. Chapter 7. Now I'm solving the example 7.2. 7.2. Okay, page. Go to the page here. Okay, 7.2. All right. Okay, page 168. 168. All right. So this is the dominant eigenvalue, the same method, using power method, the same, all right, process. All right, so now I want to focus on how to find the other one. Lambda 1 is already got, okay, is a 6 associated with the dominant eigenvector, 1, 1, negative 1, okay, y1 is 1, y2 is a 1, y3 is negative 1. All right, so now I want to apply shifted power method. Okay, shifted power method is change matrix A to matrix B, where B is equal to A minus lambda I. Okay, we give this formula before. What is a P? P is a shifted power method factors. What is I? I is identity. What is a P? P actually is a dominant eigenvalue for matrix A, which is lambda is equal to 6. And then now we use the way you solve problem using the process of power method. However, you change matrix A to matrix B. How to do that? B is equal to A PI. This one you need to know. We need to remember this formula. Yeah? And then find B. All right, and then next apply the power method. What is a power method? Is a Vk plus 1 equal to 1 over Mk plus 1 times Bv. So you apply to get the dominant, okay, Mk plus 1. To get the Mk plus 1 is a eigenvalue for matrix B. Alright, so now you apply the power method, but change A to B. Change A to B. Yeah, same, similar. You develop the table also similar. And then the last step is develop the table. Alright, so I hope you can solve question number A and question number B in the 20 minutes. Alright, so to solve B ni, okay, to get the minimum eigenvalue lambda 3, alright, by using the lambda 1, okay, to develop a matrix B is contribute to 10 minutes, alright, 10 minutes time. Alright, again, okay, you just change B equal to A minus lambda 1I. Lambda 1 is a shifted factors, okay, the maximum. And then to get the other, okay, lambda 2 or lambda, lambda 2, you want to find the lambda 2. Okay, the formula is lambda 3, okay, lambda 1b is a lambda 3 minus lambda 1, all right. The smallest eigenvalue is a lambda 3 minus lambda 1, all right. So we use this formula. So lambda 3, the smallest, okay, lambda 3 is a lambda 1b minus lambda 1a, okay, so a plus 1 lambda a. So the minimum is what? Lambda 1b, okay, the minimum, the eigenvalue from matrix B plus eigenvalue from matrix A, you can get the minimum eigenvalue, right? Okay, so by using the shifted power method, at the value of lambda 1b plus lambda 1a, you can get the lambda 3, the minimum, okay, the minimum eigenvalue. So the question here, how to get lambda 2? So this is my question, how to get the lambda 2. Okay, all right, so let's we go to the question here, all right, how, okay, by using lambda, okay, minimum eigenvalue is equal to, okay, I'm using eigenvalue for matrix B, right, plus eigenvalue for matrix A. Okay, the question is a eigenvalue for matrix A. All right. So in this case, okay, please remember this formula. Okay, I send to your chat room. Okay, minimum eigenvalue, okay, or lambda 3 is equal to lambda 1 for matrix A B. Matrix B is A minus lambda 1 for matrix AI plus eigenvalue matrix A is a P or lambda 1 for matrix A, that you get from the power method. So please remember this formula, yeah? Okay, lambda 1b plus lambda 1a will get the lambda 3 or minimum eigenvalue. All right, so from here, I will ask a question, how to get lambda 2, the eigenvalue between minimum and the maximum eigenvalue for matrix A. So I can ask you a question like this, all right? So now, all right, I love if I can share with you, all right, the way how to use shifted power method, how to find minimum, okay, lambda 3, right, based on the lambda 1b. All right, so now let's continue. All right, since we know that P is a 6, okay, so you replace A minus 6i. I is an identity, yeah? Lambda 1 is an eigenvalue that you get from the matrix A, from the question, So come on, A you know from the question, negative 6 you know from the power method, and I is a all value is 1 at the diagonal, and up the rest is 0, right? So 4 minus 6 is a negative 2. 1 minus 0 is a 1. Negative 1 minus 0 is a negative 1. All right, 3 minus 6 is a negative 3. You go to the diagonal. 5 minus 6 is negative 1. All right, so you focus at the diagonal. The rest value is a similar. Right, so that is a matrix B. All right, the matrix B is what? Matrix A minus lambda 1 for matrix A times identity. Okay, now you create a new B now. All right, you create a new matrix B. So by using the table like power method, you create a new table for shifted power method, but different B. All right. So B you replace as negative 2, 1, negative 1, 2, negative 3, negative 1, negative 3, 1, negative 1. All right. The process of the shifted power method similar to the power method. First, you need to find MK plus 1 is a maximum from the BV. Find BV. What is a BV? Is a matrix between matrix B and vector eigen. All right. And then find the VK plus 1 equal to 1 over MK plus 1 BVK. All right. So you are using our method. And then as usual, you stop the iteration because lambda K plus 1 minus lambda K is less than epsilon. All right. I use M because I want to make it different between the lambda. All right, so when you generate this table, all right, be careful. Okay, why? Because you need to find the initial value. Initial value is given in the question 100. Okay, the vector, the eigenvector is given. And then do a matrix multiplication that I teach before. B is a 3 by 3 times V is a 3 times 1. So you will get 3 times 1, all right? Negative 2, 2, and 2. And then you find the maximum, okay? The maximum for MK plus 1. In my case, I can use negative 1 or 2, all right? And negative 2 or 2. I'm using negative 2, all right? I'm using negative to make it more fast converge, all right? And then to get a very specific eigenvalue, okay, to get the specific eigenvalue, right? So now my question is here, why we choose lambda as negative value, Right, actually you can use positive, but I'm using negative, all right, with a negative value. All right, so this is my question. Okay, my question, why we choose lambda as a negative 2, not positive 2. So this is my question. I hope you can answer my question. All right, so now let's refocus, okay, to find the minimum, okay, the dominant value for matrix B. All right, so the same thing, okay, we need to find AV. All right, the formula is AVK plus 1 equal to 1 over K plus 1 BVK. All right, the same matrix, the same iteration, the same process. The important here, you control MK plus 1. MK plus 1 is a dominant eigenvalue for matrix B. Right? Okay, this is the way how to find the minimum, okay, eigenvalue for matrix A. All right, so now you can see here, okay, VK plus 1, okay, will continue till iteration 3 because negative 4 minus 4 is 0, so which is less than epsilon. So in this case, you can see that the dominant eigenvalue for matrix B is equal to negative 4. Associate with the vector 1, negative 1, 1. Okay, associate with the eigenvector 1, negative 1, 1. But we want to focus on minimum eigenvalue for matrix A. Minimum eigenvalue for matrix A is a lambda 3. Lambda 3 is equal to lambda 1b and lambda 1a, right? Is a lambda 1b is a negative 4, lambda 1a is a positive 6. So the answer is 2. Okay, the answer is 2. Lambda 1a is a matrix A. Lambda 1a is a matrix A is a 6. You got from the power method, all right? And then from the power method, you change A to B by using the B equal to A minus lambda I, all right? And then lambda 1B ni, okay, we used to find the lambda 3. Lambda 3 is a minimum eigenvalue for matrix A. So the answer is 2, all right? So Alhamdulillah, you can get all the eigenvalue for matrix A unless now you want to find lambda 2. Okay, the lambda 2 is between the dominant lambda 1a and lambda 3. All right, so the vector is correspondent to 1, negative 1, 1. Okay, the element for V1 is 1, V2 is negative 1, V3 is 1. All right, okay, so come on, we want to find the lambda 2, which is between lambda 1 and lambda 2, okay, between 6 and 2, which is the value, all right? Okay, to know the area of the lambda 2, you go to the Gauss-Green theorem because they can give you the region. All right, so come on, remember the other formula. Lambda 1 plus lambda 2, lambda 3 equal to trace A. What is a trace A? Trace A is a diagonal value of matrix A. A1, 1, 4, A2, 2, 3, A3, 3 is 5. You plus 4 plus 3 plus 5 is 12. You can get 12, right? So lambda 2 is, okay, 12 minus 2 minus 6. You can get lambda 2 is between 2 and 6. So what is the value? Okay, 12 minus x is 4, right? So lambda 2 is between lambda 1 and lambda 6. All right. So in this case, you are success to find all the values of lambda. How to get lambda 1 again? All right. I want you to focus here. How to get, my question is how to get lambda 2. Okay, lambda 2 is an eigenvalue between the minimum and maximum. Right, the formula is what? Lambda 1 plus lambda 2 plus lambda 3 is equal to trace A. How to get the minimum eigenvalue? The minimum eigenvalue lambda 3 is a dominant eigenvalue matrix B plus dominant eigenvalue matrix A. Right, it's a 2, is 6 minus 4. Right, it is 2. Right, so this is a 2 formula you need to remember. All right, to get lambda 3 is a lambda 1b plus lambda 1a, and then the other formula is a eigenvalue between a and b is a lambda 1 plus lambda 2 plus lambda 3 equal to trace A. How to get trace A is what is a trace A? Okay, my question is what is a trace A? This one you need to remember, all right, because you need to answer this question in 20 minutes. Okay, in 20 minutes. What is a trace A? Trace A is the A plus 1. Okay, A11 plus A22 plus A33 from matrix A, not from matrix B. From matrix A, all right? From matrix A, all right? So you can get the value is 12. 7 plus 5 is 12. So to get lambda 2, you minus 12 minus lambda 1a minus lambda 1b, all right? Or minus lambda 3. Lambda 3 is from lambda 1b, all right? So you get this formula. All right, so any question, okay? What you learn today? Right? Any question? And then can somebody answer me, what did you learn today? Right? So what did you learn today? What is the important, what is the objective I meet you today? I meet you today to explain how to find the area of the region of the eigenvalue lambda. And then I meet you today to find the dominant eigenvalue of matrix A. All right. And then I meet you today to find the minimum eigenvalue of matrix A by using shifted power method, where I change matrix A to B by using, okay, B equal to A minus lambda 1A times identity. All right, I meet you today to find the all value of eigenvalue, lambda 2, which is formula is lambda 1 plus lambda 2 plus lambda 3 equal to raised A. All right, so meaning that you know how to answer chapter 7 in 20 minutes, which is contribute, okay, to your final exam around, I think, 15, okay, 50% to 20%. All right, I'm not sure, it's some sort of that. It's a compulsory. Please focus to chapter 7. All right. Okay. I'm not sure. Okay. Do you want me to continue, okay, to chapter 8? All right. Why? Because I'm already give you the YouTube, okay, the material, all right, the books, okay, the e-books, okay. And then I give you also the material at the e-learning. All right. So I hope you go through before I okay, explain on chapter 8. All right. So I hope, okay, so that's why for me, to answer this question, do you want me to continue chapter 8? My answer is yes, because I give already you the material. I give already you the material for chapter 8. Right? Okay. Okay. Why? Because based on the YouTube, you can watch this video like movie, right? You can watch. Yes, thank you very much, Liu Chuan Hyo. Yes, because chapter 8 will contribute you how many percent? 25% of your final exam. All right? You can learn. Okay, you can learn. Sure. Thank you, Lo. Okay, thank you, Lo. Because I'm always guide you. All right, guide you. But you need to do self-determined learning, active learning. Go to my e-content to understand. Because the way I explain is step by step, and I'm introduce you the step you need to go through to solve the problem. All right. So now, okay, if some Hassan Fahmi said, no. Come on, Hassan. All right, I give you already. I sent to your Telegram the material. I sent to your e-learning the material. I'm always answering your Telegram. If you ask me the question, okay, I think in the short time period, I'm always answering you. All right, who are worried about the final exam, keep in touch, communicate with me through the WhatsApp, through the Telegram. I'm always give the answer. Very easy, okay, for me to make sure you understand the subject. All right. Cuma, yes, this is the process, okay, of the learning. Chapter 7, 8, and 9 is you need to study by your own much, because we don't know which part, okay, the question go on. All right, I'm not sure. All right, so now let's we go. Okay, I hope I can stop sharing. I want to go to this, okay, video. All right, okay. I hope I can share with you this video. Don't worry, I'm always guide you one by one to make sure you can understand my subject. Okay, go to page, okay. Okay, you feel that is okay, you work in the you work in the group, okay, because I hope you at this moment please work in the group. All right, so now go to page here in the books or e-content in the PDF file. Go to page 8. Right, you can go to the e-content. Okay, page 8, ordinary differential equation. Why ordinary differential equation is very important? Why we need to learn ordinary differential equation? So this is a question we need to answer. Why? Because most of the physical problem nowadays is based on the two type: ordinary differential equation or partial differential equation. Okay, for example, the temperature behavior in my room, I can say that, wow, very cold because it depends on the weather outside. Oh, the temperature behavior in this area is very cold because I'm using a high speed, very cold aircon in my area, for example. All right, the temperature behavior in this room is very cold because the size of this room is too small. And then the time duration to use this small room is very high. So the process of cooling at a small room is increasing. So there are so many parameters here. Right? For example, temperature behavior is depend on time. Temperature behavior in my room depends on the space. So I need to, I can write the model to represent the temperature behavior in my room. All right. So that's why we learn ordinary differential equation, because it helps you to represent, to derive, to govern the equation for your problem. All right. So in this case, we have two parts of the ordinary differential equation. In chapter 8, we have two parts. The first is solving initial value problem. Okay, what is the initial value problem? For example, the temperature behavior in my room is a room temperature. It's a 28 degrees Celsius, for example. So the water start from start from x equal to 0, from the high x equal to 0, for example. So in this case, I can solve initial value problem using Euler method or Taylor method. All right, Euler method is a first order of the Taylor method. Okay, Taylor method can be solved the ODE using higher order. All right, other method is a Ranch-Kata. Okay, Ranch-Kata method is very good because this is involve a simple computational compared to the Taylor method. Okay, Taylor method is complex because involving first derivative, second order derivative, third order derivative. But Ranch-Kata, right, they put the higher order derivative in the simple term. Ranch-Kata, there is two parts. One is a second order, the other one is a fourth order. So now we are going to finish for the initial value problem with these three methods, very simple. And then the last is a boundary value problem. What is a boundary value problem? Okay, the problem with the condition, Okay, what is the condition? All right, for example, I want to find the temperature behavior for this machine, for example, okay? So there is a condition. Condition is from the start, the start boundary from x equal to 0 up to x equal to n, all right? The boundary, the space is from x equal to 0 up to x equal to n, all right? So I have a boundary from y equal to 0 up to y equal to n. So I have the boundary condition for this machine. So to find the temperature behavior, I need to investigate for all the boundary conditions. X equal to 0, and x equal to n, y equal to 0, y equal to n. All right. So there are a few strategy. All right. There are a few way. All right. For the boundary, I can derive this boundary in the two element. All right. In the two element. One is a without derivative. Second is a with derivative. All right. And then because we have many types of the derivative, right? So I can also classify I can also categorize derivative at the corners, okay, at the one corners, and then derivative both corners, both boundary condition, x equal to A and x equal to B. All right. So there is a four types of boundary. The first is a derivative without derivative, derivative with the one corner, derivative with the others corners. All right. Okay, now. So this is the what we learned. Okay, we are going to cover the initial value theorem first. Okay, where is the initial kan? Okay, start the point. Where you start the point when x equal to 0. All right, when the time equal to 0, the temperature behavior is a room temperature 28 degrees Celsius. When the time equal to 0, all right, the space is equal to 0, for example. When space equal to 0, the temperature is equal to 0. So this is an initial value problem, all right? So to solve this, let's we go to the Euler method, all right? How to solve using Euler method? This is a problem. How to solve using Euler method, all right? So in this case, okay, I focus here. Okay, I focus here. Okay, I want to introduce to you that you learned before. Okay, is a interpolation. You use the Taylor method, and then chapter 5 also you are using Taylor method to find the first derivative and second derivative. You still remember? Okay. All right. So we just focus. You just focus on the Taylor series. All right, whether degree 1 or degree 2 or degree 3, right? Okay, so focus Taylor series degree 1. Taylor series degree 1 we call Euler method, right? So in this solving initial value problem, we can assume fxy as a dy over dx, okay? Okay, because we want to make it more simplest. Fxy is a dy over dx, but in chapter 3, chapter 4, and chapter 5, we never use this argument. All right, you said that you just focus fxy is a function given in the question, but here is a fxy is a first derivative y respect to x. All right, for initial value theorem, you focus this one. You focus y a is equal to alpha. A is a initial value, is an initial boundary, x equal to x not equal to a. What is a y naught? Y naught is a when x equal to a, y naught is equal to alpha. All right, y naught is equal to alpha. So you need to focus this one, yeah. X naught equal to a, y naught equal to alpha as a initial value, right? And then you always given the number of iteration or number of interval or number of point as n. N is equal to b minus a divided by h. Alright, so we generate the value of I, okay, which is xi equal to a plus ih. N. H is a size of interval, a is a starting point, I is an iteration, is a grid, all right, is a grid, and n is a number of grid, number of process that you need to complete using eigen method. Okay, I know this is a common for you, all right. H and n is a common for you, and then the new is a dy over dx equal to fxy. This is a new, right? So you focus on this formula, and then you know what is y naught. Y naught is alpha. What is a naught? A naught. X naught. X naught is a. Okay, what is a function for you to find initial value problem? All right, because we want to find the temperature behavior, the y. We want to find y, not dy over dx. We want to find y. Okay, x is given in the question, okay, from s naught up to sn. Y naught is given in the question is equal to alpha. And then we want to generate the graph for y1, okay, y2, y3, y4, okay, and yn. So this my function here, all right, is to find the value of y, okay, using Euler method or Taylor method based on the f equal to dy over dx, and then the initial value is y not equal to alpha, all right, x not equal to a, and then the size of interval is a b minus a divided by h, all right. So we want to solve this problem using three methods. What is the method? Euler, Taylor, and Rajkata. Right? So the next question here is how to find y. How to find yi. Right? So now set in your mind, okay, how to find y. So this is my question. How to find y? Y is come from where? From dy over dx equal to fxy. Right? How to find y? So we stop here. I just give you the introduction about chapter 8. Okay, so the objective for my teaching here is to give you introduction. What is a chapter 8? What is ordinary differential equation? It's a two-part. One is an initial value problem. The second is a boundary value problem. All right. And then why we solve the problem using ordinary? Because the parameter y is depend on one variable. It's only y. The temperature behavior in this room is already depends on the aircon. Okay, it depends on the aircon, the temperature from the aircon. It's only one variable. Right? Okay. Any question? Do you have any question? Any question? Right? Alright. So now, okay, again, I want to remind you for the last week here, please go to my YouTube. I said already too many YouTube, all right, too many material. I hope you can join me. Okay, you can join me, all right, through the YouTube. All right, please. I hope you can together with me. Okay. Go to the YouTube, all right, and then find the material there. Okay, do a self-determined learning. If you have a problem, let's communicate with me or in your group, all right. So come on, thank you very much for Hassan, for Lo, for Wan, for you, all right. Other student here, all right, which is register, okay. Piravan, thank you very much. Kristen, Chim, Ho, all right, for your, this is considered as your attendance today, all right. I hope there are so many students will register. Okay, see you at the e-learning, all right. See you at the e-learning. I am stop sharing. You can see my e-learning here. It's a full of material. Don't say that, wow, Dr. Noma, so many videos. No. It's not so much video. It's just I put it more simple, okay, more easy for you to understand. Go to the e-learning, all right. You can see here. All right, for today class, there is a YouTube. Okay, there is a video, right? And then for previous on the eigenvalue, eigenvectors, I'm also send you the video and also the YouTube. There is a YouTube channel here. All right, for the next coming class is a partial differential equation is a contribute to your final exam, 25%. I'm also preparing the material, so much YouTube, okay, for three types of the PDE. The first is elliptic, the second is hyperbolic, and then the last is a parabolic. All right, okay. I hope you go through the materials, and then I hope that you can continue, okay, because this contribute how many percent? 50% of your final. All right. Okay. Any question? No question? Okay. I'm waiting you at the chat. And oh, there is a question, Madam. Assignment for Euler method didn't provide FIYI. Yes, I give you at the at the assignment, I put the image. Okay, I put the image. All right, to find the Euler method. All right, I send you at the image. All right. Okay. If I want you want me to show. All right, you go to this one. Okay, watch I think this one. Okay, watch the video. I want you to watch these 4 videos, and then the question is here. Actually, it's a Google form. Maybe you cannot find this Google form. All right. So what I'm doing, I send to your e-learning. Okay, you can see here. I send you at the e-learning here. All right, you can see here. Submit your test to. Sorry. Submit your. Um, where is what? Here. Here. Submit your assignment, and then when you click here, you can find the image. Okay, the image. All right. All right. So any problem, we can go meet me at the chat and Google form. Okay, this is one from the Google form. All right. Okay. See you at the Telegram, e-learning, and Google form. Right? Any question? Okay. Okay. Meet you at the Google form. Bye bye. Thank you.